my aeroplane. Hopefully if the pen works. Yay, good start to the video. Pen. There we go. Plane. Ooh, that's a good drawing. That looks like a person. I put a head on there. Anyway, so plane is directly above ground by 5,000 feet. Okay, so that means this is 5,000. Knowing where the parts are, you can struggle on that. I can help you on that, I guess. But really, this is where I can help you. And an angle of depression of 14 degrees. What that means is it's going down. It's going to land. I don't know why I'm making them dotted lines. I don't know. And let's say it's going to an airport. Obviously, that's where a plane should be landing, right? So no word airport in there. But I want to tell you, those that watch the video, you know what's going to happen here. Those that didn't, that's helping you out here. We're assuming the land is flat. That's not always true, but an airport it is. It's got to be to land on it. So an angle of depression, people mess this up. It's like 75% of the students get this wrong. I'm just telling you right now. And every year I teach this the same way. I really make a big point about angle of depression. I throw it out there. So many students get this wrong. It's well over 50%. And it still happens every year, and it makes me want to just knock my head off of that wall over there. Right? Why they can't. All right, this is an important concept that's going to be on the test. I'm not going to screw it up. So hopefully this year is a difference. But what I showed you in the video, those that watch it, there was a bird and a dog. Right? Anyone that watched the video. If you didn't, you don't know what I'm talking about. But so this is a plane in an airport. Angle of elevation comes from looking up. Angle of depression comes from looking down. Or in this case, the plane's flying down. So it's going in a downward direction. That's an angle of depression. The angle of elevation looking up is equal to the angle of depression looking down. So that's why I put airport in here. The airport's angle of elevation to the plane then is 14 degrees. That comes from looking up. So angle of elevation comes from looking up. Well, you need a second side, so it's that horizontal right there, the ground itself. And most people don't screw up angle of elevation questions. Very simple. But then angle of depression, this is what people do. 75% of the students put that angle of depression right there, and that is wrong. So I'm going to go back, and then piggyback off of how it's equal to the angle of elevation looking up. Here's the angle of depression looking down. You need to draw this horizontal, and then there's the tie-in. These are alternate interior angles. So the angle of elevation looking up is equal to the angle of depression looking down. That's a second reason why that is where that angle measure is. Right there. Not here. If anyone puts that angle of depression there, it's automatically minus 2 points. That's the whole idea, especially of me covering this right now, making sure you don't make this mistake. So ultimately, we should know the angle of depression is there. And actually, I'm going to end up drawing a rectangle here. This is 5,000 as well, even though the plane's way over to the left. So the true angle of depression triangle is actually this one. That's the angle of depression triangle, with the 14 degrees in that little position right there. But it is often helpful to draw a rectangle and deal with the corresponding, I don't want to say corresponding, but the angle of elevation that's related to the angle of depression. Whatever, how long will the plane travel before it reaches the ground? We need to understand, oh, now that's green, that is this flight length right there. That's the traveling of the plane. So that is our x. So another thing is reading the question correctly and assigning your parts correctly. What is what there? So is what you're going to use. Purpose. Right? Opposite and hypotenuse. Try to speed this up a little bit here. So sine of 14, another geometry review thing there. Unfortunately, it's 5,000 over x. Now I'm just going to verbalize what you would do on this. You'd multiply both sides by x, then you divide by sine 14. Ultimately, these two switch positions. Whenever you have a variable on denominator, this is a quick solver. Switch them, then you're good to go to type that in your calculator. We're all in degrees, so make sure when we get back and it's the written calculator part, make sure your calculator's in. Isabella, hopefully it wasn't something I said. All right, let's get this 1-4 over with, because it really, I could go further into it, but things are going to happen later that are in this section, and in the times that we're living in right now, I think we just need to focus on the important components, yeah, I think it can be confusing over show you too many different things. That's where I'm at on this. I do want you to write this first part down though. But it is, and this really does belong in chapter 5. Chapter 5 is called, lost my pen. Chapter 5 is dealing with identities. That's usually the toughest. You're lucky probably that we're in this environment, because we're going to shorten chapter 5 a lot. Chapter 5 is one of the perennially the worst chapters to deal with, but it's just because it's weird. But it'll be shortened and simplified for you, just the main idea of it. But memorizing these identities, these are pretty easy though. We already know this. We already know sine, put up here if you want, as you're writing the thing down. We already know sine is y over r. You better, right? And hopefully you have it already tied in that cosecant is related to sine, but it's r over y. That is the word reciprocal. So there's another way we could write this. This is a correct equation. Sine of theta doesn't equal cosecant. It equals 1 over cosecant. And I put the math for it right over here. Cosecant's r over y. 1 over r over y. When you divide by r over y, multiplying by y over r. The old flipping of division. And we had that last semester, kind of going over that mathematical thing. I really don't think you need to write both rows. These are the key. Then, of course, that makes this true. You know, okay, fine. If sine is 1 over cosecant, then cosecant's 1 over sine. You know, so, you know, you do what you want. It's your notes. You know, the process of writing actually solidifies it in your brain all year long. Non-note takers laying in your bed. Oh, my kids lay in their bed during the notes. It irritates me. But then they told me I built a desk for 2 of my kids. They don't even use the desk. How rude is that, right? I did. Out of my own 2 hands, I built a desk from scratch. It was because the chair that they're using is uncomfortable. Now we got them new chairs. No excuse. I don't know if anyone's laying in bed right now. One bum in my honors math 2 wasn't even wearing a shirt laying in bed. I literally had to get. Would you put a shirt on during? Good Lord, what kind of world is this? People not wearing shirts during the notes. Anyway, little side story, fun internet stuff. Okay, and then don't write this. Sure. Hey, multiplicative inverses or reciprocals. We know 3/4 and 4/3 are reciprocals of each other. So if I multiply those together, you get 1. Guess what? Sine times cosecant, it's crazy, does equal 1. It's very simple. Think of this as variables. You don't need this for the test. It's just fun to talk about. Wait till chapter 5. This is going to be huge. Cross cancel. 1 over 1 equals 1. Right? So treat that trig as a variable. We won't do that. It's not going to be on the chapter test. But in chapter 5, you're going to do that a whole bunch. Using reciprocal identity and cross cancel. So a nice little thing to add. Little reciprocal section there. Just note to self, kind of a neat feature. Crazy. All right, there are some other identities that they try to throw you in chapter 1. They show if you open up the book, or if you look at the solutions for the review, they're going to also try to throw in this Pythagorean identity thing. I'm going to wait for chapter 5. We don't need it. We can do things the way I showed you in 1-3. That way we're focused on one method and not confused by two different approaches. I think that's what needs to happen in this environment. But we can't answer questions like this now. And I lost my little thing here. I was trying to hide that answer. So look at what it says. Find each function value. Find cosine of theta if secant of theta is 5/3. Well, they're reciprocals of each other. So if secant's 5/3, cosine's 3/5. Ain't no thing. Chicken wing. So wait for a minute, give you a chance to write. I see a lot of note takers here. I know it's hard to look up, down, and also listen to me. And I'm stalling because B's got a little bit more just to talk about rationalizing, simplifying. That also comes back big time with trig because you deal with a lot of radical side measures. You have to rationalize and simplify. Okay, I think I've stalled enough here for the second one. Okay, of course. Sine and cosecant are reciprocals of each other. So if cosecant's this, sine is the flip of that, which is -2 over root 12. There's two problems with this. One, you have a radical in the denominator. The second thing is square root of 12 is not simplified. You should simplify first. Then it makes your rationalizing a little bit easier. As a CAT student at this point in your mathematical lives, you should be able to just listen. That 12 is 4 times 3. The square root of 4 is 2. Root 3 is stuck in jail. Then cancel these because they're free to be canceled. Now this is 1 over root 3. Then rationalize. Otherwise, if you multiply both top and bottom by root 12, then you are creating, some more. You still have to simplify, and it's a little bit more complicated. So sine is then therefore negative root 3, right? Okay, so we got a little rationalization. We got a little bit of simplification of the radical. Some of those mathematics happen in ratios. All right, what time do we start? 9:10? 21 minutes in. Okay, gonna move on. I stole this from the internet. I had a form of this, but I think this one's cleaner. This is something that can help us the rest of the year. As a matter of fact, I'm going to say this the rest of the year. All students take calculus. Love it. And actually, I love the representation that I stole off the internet. I love this picture that shows the drawing of the triangles. It shows the coordinates, x, comma, y, and then you snap back to r. This is how I'm going to make you on the test draw triangles, at least for this first test. So you know when I have coordinate trig, I draw the coordinate and make a triangle. Right? And hopefully that's happening. It will have to happen. But what all students take calculus is an acronym, or a mnemonic device would probably be a better thing. I can't think of another one. Roy G. Biv, that's for the colors of the rainbow. But that's just all the first letters. I'm trying to think where you use different words, but it actually makes you remember something else. But anyway, all students take calculus. This is what this does for us. Well, let's analyze what all means. When you're in quadrant 1, you're going to have a positive x, a positive y, and r is always positive. So if your angle measure is in quadrant 1, every single trig function of that angle will result in a positive set of ratio, or positive ratio, because you have positive over positive. That's what all stands for. All stands for every single trig function of quadrant 1 angle measures will be a positive ratio. But then when you get into quadrant 2, that's negative x left, positive y up, and then r is always positive. So again, I'm emulating with that little squiggly, if you saw me drawing over that black there, that's how you move and how you make your triangle, yet again, if you're still confused on that. All right, but look at, you have a negative x, and that's the coordinate right up here, coordinate trig. But you have a positive y. So who's y over r and r over y? Sine and its reciprocal brother or sister. But student stands for sine. Sine is positive in quadrant 2. And then who else? The other one that deals with r and y, which is cosecant. So you'd have to remember cosecant's tied to sine. So the student stands for sine, one of our original trig functions. I like calling those the originals, and then the reciprocals are the other ones. Take, if I go left and then down, that's negative, negative. R is always positive. So y is take tangent. Tangent is y over x. That would be a negative over a negative, which is a positive. So tangent and its reciprocal brother or sister, cotangent, are positive in quadrant 3. Then calculus actually stands for cosine. We do have a mistake here. Caught this last hour. So sorry, whoever I stole this from the internet, I caught a mistake that you got there. That's actually negative x, comma y. Wrong! I just made the same mistake. It's positive x, negative y. So they have the coordinate right up there, right x, down y, but then they wrote this wrong. And I just did it again. The positive x and a negative y. Right? And you can see that in the moves here. Maybe I'll do a highlighter. Right, positive, down, negative, r is always positive. That's how you draw your triangle. Anyway, who deals with x and r? Cosine. So every time I'm doing these, I draw a coordinate plane and I put my ASTC, just as a double check. I'm going to talk about all students take calculus all year long. You're going to have to hopefully remember that as a nice little aid. Okay, yeah, I'll leave this up here for a second. But again, I'm making a video. If you needed to take a few more parts from this, just pull the video to this part and pause. Especially this. And I have this type of, what do you call it, microphone on when my other one doesn't work. You can hear the clicking in the screen. Okay, 5, 4, 3, 2, 1, let's go. Not doing those, not doing that, not doing that. I just want to keep it to questions that we had kind of in section 1-3, but it's just a little different way of asking it. So I'll slowly read this. Suppose that an angle theta is in quadrant 2. Stop. I'm going to go ahead and draw my coordinate plane. I'm going to do what I said I would do in a lot of these questions. I put my ASTC here. Remember, 1, 2, 3, 4. Some people struggle with that too, just struggle with the coordinate plane. And that's why trig is a problem. Drawing coordinates correctly, x, comma, y. Run into all these things. Quadrant 2, so we're here. We're in this, here's where the triangle is. I want to make a note to self reading. And then sine of theta is equal to 2/3. In the chat, what does 2 over 3 represent in terms of x, y, and r? In 4, 3, 2, 1, 0. Nobody? I think someone's typing. What does sine of theta represent? There we go. We got Michael first, and then Natalie just popped in. Colin and Natalie, close enough. All right, thank you. This is y over r. So that's part of what you need to know, and this is huge the rest of the year. Circics or ticks, just knowing when I'm given sine, what are those letters. So when I draw this triangle in quadrant 2, I don't know x, but I do know y, which is 2, and I do know r, which is 3. So that's the drawing there. So I should know that in order to find x, I need the Pythagorean theorem. Wrong! That's 2 squared. My bad, dogs. I caught it quick. of 2 squared equals 3 squared. I don't know why I put parentheses there. 4, 9, 9 minus 4 is 5. Square root. Now, dealing with this with my math 2 honors. Algebra student puts plus minus on that. Definitely. It's a plus minus answer when you square root both sides. For this particular question, because we went left, it is negative. So this is negative root 5. Or, here's what else you should do. Okay, all students. Of course, sine. Well, sine's given. How could you miss that? So sine's 2/3. Says find the other 5 trig functions. So I didn't even need to write sine. Oh, and then just what we covered before. Of course, cosecant's the flip of that. So I didn't need to do anything to find cosecant. That was our reciprocal identity. But what I would do right now is, okay, sine is positive, so is cosecant. All the rest are negative. And you might want to mark that right now, like before you go and continue, so you don't forget. That's what the ASTC does for you. That's the difference between geometry, trigonometry, and calculus trigonometry. We're in coordinate planes. We can get some negative ratios. Weird. Right? And then we could just go, okay, Kixer. You don't know this? Then you got to get that figured out. Oh, no. Secant is 3 over negative root 5. And then you root 5 both top and bottom. Negative 3 root 5 over 5. And then tangent is y over x. Y over x, that's 2 over root 5. I do have a little green negative there left over. But anyway, then that ends up being negative 2 root 5 over 5. Same rationalization. Multiply both top and bottom by root 5. Don't flip this. Flip this. Or look at up there and cosecant is, or cotangent, sorry, is x over y. Right? You flip that that nasty little answer for tangent, you create reducing problems. Right? It just makes it a lot tougher. Okay, so this is like a 1-3 question. 1-3, I actually gave you the coordinate. Then you had to find r. This one gives you cryptic information where you have to figure out what 2 letters you have and then find the 3rd letter. Very similar, right? This is the question when you look at the books way of doing it, they use identities, and that's what's not going to make sense to you. Just giving you a heads up for those that do their homework correctly and do the right thing and are internally motivated and have that internal locus of control. Ooh, going back to August. Coffee break as you take this next example. And the last one. Promise. You have to hurry up, though. No time. Hey, this is nice. I only have to find sine of theta and tangent of theta. So I just have to find these 2. Not all 6. That's nice. Okay, now this is cryptic information. In the chat, think about it before you do it. Load it up, but don't press enter. What quadrant is cosine of theta going to equal a negative ratio? What quadrants are possible where cosine of theta is a negative ratio? 5, 4, 3, 2, 1. I see some people typing 0. Okay, now we don't know if we're right or not. I want to see, and if you answer it and then see some other people and want to change it, go for it. What quadrants would we have cosine of an angle measure being negative? A, S, T, C. We only have one answer so far. Interesting. This is going to be it. Last hour we had a lot of answers. Ooh, what does S and T mean? Oh, okay. Tell me, Michael, what quadrants those are, though. I like it. What quadrant numbers? I guess, Michael, we'll end with you. I thought I saw a lot of people typing. Afraid to get it wrong? All right, Michael got it. Hey, what happens, 6th hour? I had a whole ton of people. Right, so what does all mean? All means they're all positive in quadrant 1. So it can't be quadrant 1. And what does C mean? Cosine. Cosine's positive in quadrant 4. So it's not these two, it's these two. Now, read this. Between these two quadrants, which quadrant is this true? Sine of theta is greater than 0. So this is what you have to do as a student, analyze what you're reading. So between 2 and 3, where is sine of theta greater than 0 or positive? Waiting for the chat. 3, 2, 1, 0. Michael, probably can only give you again. I feel like we lost the rest of it. There's Natalie. Good. We got somebody else playing the game. That's the whole idea of this. S is positive in quadrant 2. That means it's negative in quadrant 3. Because tangent of an angle measure is positive in quadrant 3. All the rest are negative. So this is the quadrant we're dealing with yet again. So the point of this question, or at least me covering it, is helping you read through it. What you have to pull out of the information for ASTC, knowing what quadrant you're in because of the two things that are given. Cosine's negative in 2 and 3, but sine's positive in 2. So this angle measures in quadrant 2 again. And then when I draw it, I want a different color. Go through this fast. I think there's just a little bit of rationalization. I should put this in the chat, but we should know that this is x over r, and only the x is negative. R is positive. And then Pythagorean theorem, negative root 3 squared plus y squared equals 4 squared. This is 16. This is 3. Subtract 3 from 16. Oh my goodness. Wrong. 13. When you root it, you get plus minus. That's why before we see this, you could have been up or down root 13. We don't know. That's why we have to read the question completely. Well, it's actually up because we're in quadrant 2 because of that second piece of information. Now we can fill this in. X, Y, R, sir. Sir is root 13 over 4. Right? Yes. Ooh, tangent's a little bit of a bugger. It's y over x. Nothing cancels. So you have to rationalize. Actually, it's not as bad as you think, just being able to write your final answer. Sure, it's 3 on the bottom, free. 13 is prime, 3 is prime. There's nothing that can simplify. So you just multiply 3 times 13. Right? And it's root 39 over with a negative in front. Okay, so really understand that this is almost exactly a 1-3 question, coordinate trig, but they just give you some information. You got to find out what quadrant you're in. Find all the sides, or kicks or ticks. All right, I'm done. Here's what we're going to do. I'm going to stop presenting, which means I'm going to have to stop taping. I'm going to find my end it thing here.